On page 3 we look at the domain of a composite function, for example the domain of f of g of x. Now remember that g of x goes into f, right? G of x is fed into the function machine f. So whatever comes out of g of x has to be part of the domain of f. And that's what this diagram here illustrates. Everything inside this big circle here is the domain of g, so it's a possible value of x, but it's only those values of x that fit that when you take g of x, then end up in the domain of f that we can take. So it's an extra restriction on the domain. Right? Whatever comes out of g of x must fit into the f function, must be part of the domain of the f function. So in this example, down here, this example 2, if you have two functions, here the two functions are the square root of x minus 5 and x plus 2, we can try to define what the domain of the composite functions f of g of x and g of f of x are. So looking at this function, this f of x function here, remember that the square root must be the square root of a positive number, or 0 or a positive number. So the x minus 5 has to be bigger than or equal to 0, so x has to be bigger than or equal to 5. So that's the domain of f, and the domain of g is just everything. There's no problem with adding 2 to a number. You can add 2 to anything. So if you're looking for the domain of f of g of x, well, think about this x plus 2. When you take this x plus 2 and feed it in over here, well, the x plus 2 has to be bigger than or equal to 5. Right? The x plus 2 has to be bigger than or equal to 5 in order to make the square root 0 or more. And since x plus 2 is bigger than or equal to 5, that means that the domain of f of g of x has to be x bigger than or equal to 3. Everything that from 3 upwards works. You can try that out a little bit. If you try x equals 4, you're going to have 4 plus 2, that's 6. And then you put the 6 in here. That's the square root of 6 minus 5, the square root of 1. Okay, that works. However, if you try a value of x that's less than 3, so for example, if you try x equals 2, put x equals 2 in here, we'll have 2 plus 2, that's 4. You take the 4, you put it in here, 4 minus 5, it gives you minus 1. Can you take the square root of negative 1? No. So that just illustrates that the domain of f of g of x is x bigger than or equal to 3. And then if you try the domain of g of f of x, it doesn't actually matter what the output of the square root of x minus 5 is, because g of x can deal with anything. You can take any value and add 2 to it. So the only thing we have to worry about is that whatever value of x we take, we can then get the square root of x minus 5. Okay, so the domain of g of f of x is just x bigger than or equal to 5.